my senior project, I worked on hidden Markov model and their applications. I especially worked on the predictive maintenance problem and use a turbofan engine and aggregation simulation dataset. This dataset is taken from NASA's Prognostic Center, as it can be seen here. Coming back to the dataset. The dataset has 28 sensors and 200 simulations. Each simulation is in a run till failure manner, and they start from a healthy state. Since we try to predict the remaining useful life in the predictive maintenance tasks, it's informative to look how the sensors correlate with the remaining useful life. As you can see here, the sensor is quite good with high correlation values. Here is some further visualizations of the data. Here are how the 28 sensors with each different color changes in a motor's sensory recordings. Starting from the healthy state here and going to failure here, we see some sensors are positively correlated, some negatively correlated, and they follow a pattern. We try to capture this pattern in our models. Here is some further visualizations. When we select a single sensor which in each motors, we see here how their value changes from starting from healthy state here and to failure here. Moving on to the model, I built a hidden Markov model with 8 states to capture the system's behavior and train it with the training data. After the training, I had these 8 states and ordered from the big remaining useful life to smaller one, which means a healthy state to a worse state here. The system captured satisfactorily states with different remaining useful life and low standard variation in each state. Using these averages and the system's posterior state probabilities, I made a prediction of the remaining useful life. Here is the state transition matrix. We see here that the systems try to move to the states with worse health condition. It's also expected results, and the system captured it really well. It starts from, for example, 0, the best health state, it goes to first, and from the first to third, from the third to fifth and sixth, and from there it goes to their final worst states with low remaining useful life. After the training, we see that depending on the posterior probability, how our predictions done here. Here are 2 state changes and 3. The system has been in 3 states till its failure. Here we see that the Markov model captured the pattern naturally.